just let us know in the Slack channel. Cool. I guess we're just gonna start because the beginning just some introduction slides. So good afternoon, everyone. Welcome to our first class of the Python Bootcamp 2020. So I'm trying to skip to, okay, cool, next slide. So, oh wow, is that an autoplay? No, stop. So this Python Bootcamp is co-presented by the GDG Cloud Edmonton and PyYYC. And we're really fortunate enough to have a lot of innovation leaders to help us to form this team of 7 local leaders in Python and data science. And we are looking forward to build active and engaging communities by having this course. And our main purpose is not only like, like a university lecture that we, you just go to the class and listen to the prof about the course lecture content. We really wish that we can stay connected beyond the class. Not only the class leaders and coordinators are facilitating this course, but you as a participant also helping to facilitate this course and also build a more welcoming and engaging developers community in Alberta. So for example, we have our Slack channel that here we're gonna, if you have questions about class, you can post, and anything, you don't know about coding, we have our course leaders and you follow classmates to be there to help you. And in this course, we have also 4 course coordinators will be in the Slack channel to answer your questions. So we did a pre-class survey before the class. So we think it's good for us to share a little bit about who are you to are attending these courses. So the first question is, okay, so a little background, we have we have about 100 participants, and we received, for the past 2 days, we received 35 responses. And in these 35 responses, the first question is, what are the factors that motivated you to sign up for this course? And over 60% of you said, I want to improve Python programming. And 25% said, I'm interested in the mentorship from experienced Python developers and data scientists. And about 8% say want to learn Python industrial user cases. And about 1% said, I want to teach my kids. That's cool. For the next is, does your work or study require coding on a daily basis? And we can see about half of the participants will require their work or study require coding on a daily basis, which is very good. And among the 35 responses, the next question is, what is your expertise level in Python from 0, no experience, to 5 expert? So there are about 12 of them, which is about 1/3, said, well, I don't have experience in using Python. And about slightly 30% of them have Python experience from 1 to 4. And 1% is really experienced in Python. But we also ask, are you familiar with other programming language besides Python? And the answer is actually 80% of the participants know other language besides Python, which means for this course, a lot of people have the basic programming experience and trying to or wanted to brush up their Python experience or to learn Python as their additional programming languages. Another question is, how do you rate your knowledge in Git and GitHub from 0, no experience, to 5 expert? So as we can see, there are about 1/3 of the participants have a pretty good GitHub experience from 1 to 3. I think I have one more slide for that. Okay, cool. So that's the pre-class survey, just to get to an understanding of our participants and your fellow classmates. So the questions next is, who are we and why we are why we are organizing this Python bootcamp. So I'm Shenli, and I'm one of the co-founders of Google Developers Group, Cloud Edmonton. So we are an official chapter of Google's worldwide network of cloud experts, developers, data scientists, and cloud engineers. And why we're organizing this course is our group has about 600 members, and we have volunteer that over 30 volunteers to help us to organize our events, including our machine learning bootcamp, our Python bootcamp. Like, I'm one of the volunteers to help facilitate them. And we organized over 20 events for the past years, and we're only 1.5 years old. So what we really want to is we want to help our members to grow by advancing their technical skills, and also networks, and also career development. And running those course and the bootcamp is one of our core events to achieve those goals. And we don't want to have the lectures to have the course and you just come here to attend the course. We want you to be part of it and be part of the community and help us to build Alberta's developers community. So next, I'm gonna hand over to Carson, who is the the founder of the PyYYC in Calgary.
Hey, welcome all to the Python Bootcamp. So I'm Carson, and actually the organizer leader for the Calgary Python meetup, PyYYC. We have 1,300 plus members, and people find it very useful for learning and finding new opportunities. We're collaborating with many groups, as for example, we're collaborating with GDG Cloud Edmonton, and we also collaborate with a lot of other meetup or event groups, both in Edmonton and Calgary, and actually among Canada. So thanks to this virtual event, we can make better connections and collaborations. So if you're willing to learn about Python, feel free to join. Our mission is to learn and share with what we know and help each other grow. So here we go. Go to the next slide, please. All right, so this course is structured in such a way that you can learn both the Python and gain some knowledge into some industrial usage. So for the first 2 weeks, you will learn how Python works. And by the end of the first 2 weeks, you should be able to write some complicated Python program to achieve some complex function. The third week will be web development with the most popular frameworks and the latest technologies such as async. The last week will be machine learning. So it will cover both supervised and unsupervised machine learnings. I've gathered a crew of the industrial experts with industrial leaders. So we have like team leads, senior developers, also other meetup organizers. So hopefully you will gain a lot from this course. Yeah, so let's get started. I'm gonna hand it over to Peter, who is a full stack developer at Showpass. He has been teaching Python for a few years, and he's pretty good at it. Okay, Peter.
I just need the share screen to be enabled for me.
I just stopped the sharing, and Peter, you can start sharing the screen.
Okay.
And I forgot to mention while Peter sharing his screen is we will, for this class, we will have 2 sections. Each section is 1 hour and a half. Then we will take a break in between for 10 minutes. Our class is about 1 hour long, and we would really appreciate you type your questions in the chat box when Peter is giving his lecture. And after his first section, he will go to the chat box and answer the questions. Okay, cool. It's all gonna hand over to you, Peter.
All right, thank you. Thank you,
sorry,
Shinji.
Peter.
Oh, sorry. That was all right.
I just suddenly forgot one thing to say. So we will have 2 Python license draw from the participants after this session. So for those who don't know, PyCharm is IDE that you can write code for Python. It's pretty powerful and it has a free version, but this license will draw a 1 year for the pro version for PyCharm. So the winner will be announced after the session and probably will be announced through email, I guess. Yep, that's about it. Go ahead, Peter.
All right. Hey, everybody. I'm Peter. I'm a full stack developer for Showpass, and I do this lecture here every once in a while for other organizations, mainly Momentum.org, and it's mainly for people who have tried to change their path in their careers and try to learn something different. So what you have here is that what we have here is like a really general sense of how Python works, or also like how to program it in a very elementary way. And the next few weeks we'll build out on that knowledge so that you can hopefully work on your own application. So yeah, why Python? And it really depends on what you want to do. Because like there's a lot of different tools out there, and Python is just one of those tools. And amazingly, Python is good at a lot of things. Few things they're good for: data science, machine learning. As you can see, we have a lecture on that. Web development, I know for sure because I use Python for web development, and script automation as well, because I used to be a QA person, so I use a lot of Python and a lot of Selenium to kind of automate little tasks. What Python is not good for is app development. There's no real good application or like frameworks for Python to make apps, unfortunately, and that's what really Kotlin and Swift is for. And for OS development, and it's only really because Python is interpreted. Like most Python, most of the time Python is developed with an interpreter, and interpreter, what it does is that it's another program that takes your program. So like kind of here, I can actually show you like a tiny picture of what I mean. Is that when you run a program in like operating system, you just have like this program right here, and you send it to like the command, say OS run this please. But for Python, what you really do is that OS run this interpreter, OS run this, then you have another like file that you input into the interpreter, then you run it. So you always have to have this little thing there. But that's just like one of the things that Python is actually like it's actually gives it a lot of different strengths and weaknesses because of it. And one of the strengths it has, because it's interpreted, is that let's say you want to run your program, you don't really have to compile. And if I don't know, some of you guys are like very versed in computer science, like there's a step from writing code right here, and there's like this little thing called the compiler that churns out machine code, like X, like bytes already, right? And this is what the OS can write. But yeah, like for Python, really the only thing you have to do is you have the code. Instead of compiler, you have the interpreter. And the interpreter already runs the code at that point. So it's very easy to kind of test out your experiments. Let's say you want to do like, you have some application, you want to go fast at it. You don't have to worry about waiting maybe like 10 minutes or whatnot to compile. Actually, there's a really extreme case that I know for sure. When a long time ago, I tried to compile my own Firefox. And that took 4 hours just to make it run. It's very painful. So we're very lucky that like tools like Python or even just Ruby and other things exist, because they let us go as fast as we can, almost as fast as thinking. But that's kind of how it is. But yeah, that's really like why we should do Python. And so for the next part in here, I said Python versus X. And I just want to compare it to different other tool set that we have. Let's say for C example, Python versus C. It's really like it's actually quite hard to define, as I said before, because like they're different tools. It's kind of like comparing a hammer to a saw. They're used for two different things. So it's actually like, as much as like you see a lot of in the different places in the internet that you say use this for this, it's just like they compare like different languages to get their performance and whatnot. Yeah, that's definitely comparable in that case. But you have to think about it as different tools. Python has lots of libraries on data sciences, on web development, and on data processing automation. You use Python for those. If you want to make a game or an operating system, don't use Python, or maybe use Python as a top level, but everything else uses, because as I said before, Python is good for automation. So use C or C++ for making your graphics engine. And yeah, just think about it that way. Like the different tools, there are different tool sets, and you'll just be upset at like figure out what you want to choose. What you want to choose. You want to choose. You want to see the problem, figure out what the problem means, then choose the right tool for it. So all right, install in Python. I believe you guys already had the five-page little primer to start Python off. For today, I said in the Slack, we'd like to use the collaboratory notebook. So the website is, I'll type it out right here. It's, I'll type it right here. Hopefully you can see it. So it's collab.research.google.com. Just go to that webpage. So I'll do that right now, right here. And I'll just wait like a few seconds so people can type it out, collab.research.google.com. So if you have hopefully you have your Google accounts ready already. Google takes, I don't know, a few seconds to get going, like to get your own account. Excuse me. And I'll press enter on here. And this should be the screen that you'll see right here, although this mine's kind of exaggerated. What you really need to do right now is just click this one here, new notebook. Let's go new notebook, and it'll open up a new page for you. It takes a little while. For some people, I'll get lucky because I already was running. I'll just change the name up here. And we're actually good to go. We can experiment as much as we want. It's awesome. I'll just do a quick run through with the application itself. You see right here, this is a code block. A code block is where you put code. So yeah, so you can put whatever you want in here, X, Y, Z, whatever. But this will be run as code. And to run code, you see this run right here, this play button right here to the left side. Just press that one, and it will take a little bit of time to start up. Because what's happening is that Google's assigning you a new machine. So right here is an error because like I'm just playing around with it. But yeah, so now you have a new machine running in the background just for you. It's not using a computer. It's not using a computer resources. So like you can have the heaviest program you have in here. It's gonna be okay. Then if you want to put notes and it's you want it to be formatted notes, this one is markdown. So we can go GDG bootcamp. And now right here, it's markdown. So yeah, it's great because like let's say you want to preface this this code block right here. So what you want to do is move this up with this button right here. See this button right here? It kind of moves it up within cells. So I'm going to put it up on top. So now I have GDG bootcamp. And yeah, so like you can actually have like a quick little thing to put in here just to say, this is what I'm working on today. And yeah. So yeah, we're going to start right now with the first thing that we usually do in a tutorial, which is a hello world. I just want to double check if anyone is stuck. No one's stuck, right? Oh yeah, thank you for putting that in there. I'll answer these questions during the break. Just letting you know. Just put it all in there. I'll come back to it. So yeah, if you have a question right now, unless it's super urgent, someone would get. Let's see. That's a good suggestion, but I'm not actually using my mouse too much. I'm not so sure how to highlight it. Let me see. I'm on the web app, unfortunately, so it's going to be a little bit hard to do that. I'm sorry about that. Like I'm not a Zoom person, but okay. Let's move on, unfortunately. But yeah, as you say, how to get the collab. Just go up a little bit. You see in the chat. Go in the chat. There's one from GDG Edmonton. HTTPS collab.research.google.com. Just open that up in your browser. So we'll just wait for like a few more seconds. And I just want to reiterate, if you're lost right now, this entire lecture will be available to you later. I'll give my own copy, so that you don't have to worry about copying notes. If you just want to listen and just take it all in, that's absolutely fine. You can have your own. If you're a type that needs to write notes, this is like the next level notebook. Just let you know, is a great piece of piece of software. But yeah, so we'll get started with the hello world, and the hello world is quite simple. You just go type print, then put hello world. So this is our hello program, and I'll press play, and as you can see, just types hello world. And just to some basic parts of this hello world. Print itself is a function, and you can actually check it out. It's function. It is built in, so yeah, it's like just part of it. And this part, hello world, we define as a string, and we call it inside these brackets. And I don't know, some of you guys are already kind of noticed what it means already. But don't worry at the moment. We're just naming it. I'm gonna explain these parts a little bit better. So what I can do right now is that I can actually write some notes right here. So print, this is a function, hello world is a string. Then I used hello world as the argument, as arg to print. So right now it doesn't make sense. Maybe some people, but some people it makes total sense. That's absolutely fine. So I'll make a new code piece in here, and we'll just get going to like some basic stuff, right? So in Python, we're gonna be able to move around things, kind of like assign them to different names. And the way we do it is it's really called variable assignment. And I just want to let you one thing about Python is that I just go here an object. I want to put an object into something. Let's say hello world, right? Just for the people out there who are kind of a little bit more keen, Python's gimmick is that everything's an object. And what it means is that when you assign something to Python, as you saw, we put an object, right? Object equals hello world. What we're actually doing is that in the universe where Python lives in, where it's working in, the interpreter or whatever, Python's making this object right here called hello world. All right. And it has a naming, like it has a list of names here. So it has, I have a name, an object, and I'm kind of pointed in there. So whenever you assign a name to a variable, that's really what you're doing in Python. You're kind of assigning it, like you're making something in its universe, and you're giving it a name right there. So later on, you can actually access like wherever you are in the, like wherever you are in the current place you are in Python, you can get it to say, oh, the object that I'm looking for is that hello world, what I've defined before. So just keep that in mind. And that's really like the basic way we kind of like, give names to things. And for the naming, I just want to let you know that certain words are reserved, and you'll note it more later. It gives a very specific error. So like I'll go here, if equals if word. And if I actually play this, it'll say if world invalid syntax, because if right here is this very specific term. And there's a lot of there's not a lot of these, but if you see this weird thing right here, you'll know that it's a keyword. It also highlights it a very different way. There's also like other things like for, and, or. There's just a few of them, but just be aware of those. But also like just to give you like so like the liberally how you can name things. Just a second here. Okay. Is that you can go you can pretty much like alphanumeric, although the first thing has to be always alpha, and you can put an underscore. Sorry guys. Underscore and a 1-2 combo. 1-2 combo. Punch jab, the kind of deal. But yeah, so this is really like the only rule that you have when you want to name your variables, is that underscore alphanumeric first letter has to be a letter, not a number. What you come later is that like Carson, or like in the next session, there's other additional naming schemes, but this is really like the basic one. Okay, let's go back if there's any comments for me. You have you make your own collab file. But I'll just answer this very quickly. Make your own collab file, please, because like if you want to follow through, it's good for you to follow through. Like that's really like what I've realized help a lot of people or some people. If you just want to listen in, I said before, you can listen in. I'll give my notebook out to people. I clean it up and whatnot. Okay. Unfortunately, I can't help you out. I'm kind of tight schedule, but network occurred requests. It's a very complicated error. My suggestion is to like hard refresh, Control Shift R, or F5. Then make a new notebook again. Then press play. It should, because like this is kind of like in the system already, unfortunately. And unfortunately, I can't kind of like help you guys out individually to solve these problems. So, okay, I'm just gonna continue on. Before we move on to the next part, I just want to kind of talk about like one person said the comments and whatnot. There's a few ways to do comments. One way is to do this, a comment, and comments will not get executed in your code. So there's a comment right here. So if you go print hello world in here, this won't run because it's commented. Then there's also the triple string, triple quote, and the triple quote runs multi-line, so it'll only terminate when when you've done the next triple quote. So these won't run anything. Oh, actually, well, that's a string. Sorry, like that's well. Okay, I got two events in there, but this is actually a string, but it's for functions. Okay. I got distracted by one comment there, but this is like the comment. I'll talk about that later. Sorry about that, guys. Because this is kind of like out of my course outline, unfortunately. But yeah, I just want to make sure this is a comment. If you see me do it before when I did a slash like this or a hash like this, it's actually a comment. So it doesn't get run. Only if it's not there where it gets run. Right here. Okay. So I'll make a new one right now, and we'll talk about so types and type conversion. So the funny thing is that I have, like we're right here. So we're right here, basic types, you see guys. I just want to reference that before we go. Okay. So I'm gonna make it bigger. You guys can see, right? Let me double check. My browser is Firefox. It's kind of like being in Twitch. I gotta answer every question every once in a while. Okay, so there's a few types. There's a few basic types that we really care about. So there's the numeric types. Numeric types are integers, floats, and complex numbers. Amazingly complex numbers. There's strings, strings and characters. These are basically like alphanumerics and special characters, like A, B, alphanumeric, alpha, and actually numeric as well. But they're not translated as numbers. And also like special characters like question mark, slash, comma, and whatnot. Those can exist in as a string. And there's a bool. A bool is true or false. This is very useful later when we do I'll just put here alphanumeric. When we do later when we use expressions. And there's a very specific one called none, which means none or null. Kind of hard to kind of describe it, but yeah, when something means nothing. There's a very specific one in there, none. But yeah, and the good thing about these is that like what you expect in this is that like numbers work with each other very nicely. So let's say you have 1 here, which is obviously an integer. You can add a float, which is usually like something with a dot. Float meaning a floating point. So the point being this decimal point. When it's represented a different way. You can ask me later about that one. But yeah, that's a floating point, and this actually works properly. Like it'll be 2.25. It won't complain, which is nice. So in other cases, we'll go print here so that we can see everything that we want to do. There's like, yeah, 1.5, minus 1.25 will be 0 and whatnot. So it converts back to, it doesn't convert back to it converts back to just a float. So just keep that in mind. And like as I said before, there's different types, and for numbers they're very compatible with each other, but there's certain things don't go together, like those strings and integers. So if we add, like, I'll define a string, by the way, to define a string. Actually, I'll make a new code text in there. These are strings now. So define a string, I'll tell you what, is kind of like this string, or triple quotes will be what I kind of move way too fast. It respects the spaces and the white spaces. So this is a string, and we can assign it to a variable string. And if we print this out, this will actually respect the new lines. If you do this, new lines, if you do the new lines on a normal way of doing a string, which is the quotes, it'll cry because it didn't know what it doesn't know what it means. It doesn't know the new line. And just as an aside, you can define strings with a double quote. So another string or a single quote. It doesn't matter. My only comment to you is that you need to be consistent. And there's going to be a lot of different ways to format this. But yeah, just consistency is the key. So let's just check how people are doing. What types are dates? Dates are compound types. They're actually they define the date as a class. Well, we get that later. Like I'm not over it, unfortunately, but it's definitely a custom. It's a custom type. And from now on, I'll answer those questions after. I want to go through this so that we can kind of like have this nice, hopefully flowing lecture right here. So now, as I said before, there's certain things you have to be wary about. They're different types. Numerics can work with each other, but strings cannot work with each other. Strings cannot work with numerics. So this obviously will fail because, like, how can you add a string to a 1, right? I'll just say type error, right? But this is a lot more nefarious right here. 12 plus 1. You think that like maybe you're naive, maybe you think it'll work. It's a number right here. That's definitely a number. Add 1 to it, it'll still be type error because it'll understand it as a string. And what you can do is that, amazingly, there's a lot of ways to kind of go around this. Is that you can make sure that they're the same type. So there's a bunch of functions that we can use. There's the int function. Let's make a text here. So there's the int function, which actually I'll have to get to. Like, there's a lot of ways to convert it. So there's an int, like, and the function is like something you insert into. I don't know what I'm talking about, but there's an int right here that you can use. There's a float that you can use. There's a string that you can use to kind of like make them compatible with each other. And then how to use these functions, as I call them, is that you put the argument in here. So input string right here. So input float, input string, and this one input whatever you want, number. What you'll find later, like when you study a little bit more, try it out, you can see that they're not actually limited to these types of inputs, but we'll just use them for now. So to solve this error we have right here, that like the type error, what you can do is that we want to convert that 12 into an integer. So now this one is like 12 int 12 right here. Then we're going to do is int 12 plus 1. And we've used like the variable assignment right here, a little bit a few compound things and whatnot. But yeah, we've assigned the return of this int into 12, and we use int 12 plus 1, and this should run and should say 13 because we changed the type. We've changed the type. And yeah, so like there's a lot of ways to kind of use this. Let me just trash this one. Like you can actually use a string, because like what happens is that if you add 12 and you just want to go like what's this, if you just want to add like a you know, how old, you know, like, say it's like what time is it now, hour, and you just want to go like answer it being you want it to be, you know, you want to tell, they can combine together to say like it's like 13, like you know, 1 o'clock. It doesn't work because it's type error. So what we can do is that we can actually assign this to a string. So 1 equals string 1, and we just go add this together and play it. Then it kind of like combines it together. So add. So I went a little bit forward in here in that like the string, you could add them together, but we'll talk about it right after in a few I call this in a few minutes here. Okay, where are we right now? So we're at the basic types. We finished that. So we have some basic types. Actually, I still have to talk about some few types. So there's still like the trues right here, which is like a very specific thing. This mean like a you know, like logical true. You know, if you have an expression, which we'll go back in a bit, an expression that'll write to true or false, then you can compare true or falses with like, you know, or you know, and, you know, like the usual things that you think that you can use with logic is going to be false and whatnot, or you know, like that kind of deal. Or we can go or in here and you can just play it, returns true. So that one, and then lastly, the none one is very specific. This none here is unique. Like if you want to mean something that doesn't exist, you know, it's very specific. Like it doesn't even return anything. So you play it, nothing happens because it's nothing. Amazing. And you know, if you want to check these like compatibility for sure between types, you can just call the type function. So there's a type here, and you put like the number 1. You put in there. It's an integer, it says right here. Although they're kind of short term in it. So a string right here is going to tell you str. This is a string, and yeah. So there's a lot of little things right here that you can do. And I'll leave it up to you to like try it out and whatnot. This is, you know, like you could just do this to everything. So you can even go none, and amazingly none has a type, which is a none type. This actually goes back to the idea before I told you everything's an object. So everything has a type because it's an object. It comes from something. It comes from like that meta, you know, the meta thing that it comes from. Everyone has those. So now let's see where we are. So we're going numbers and arithmetic. I'm just gonna go with like what basic functionality we have. Actually, before we go, I'll just see if people are lost. Yeah, thank you. That's very nice. Yeah, and as I said before, you just want to listen. I talk relatively fast, so I'm sorry about that. That's just me being, you know, a little bit excited and nervous and, you know, kind of just like enthusiastic. I talk very fast. If you can't follow, I'm going to be try to slow down as much as I can. And I just want to reiterate, these notes are available to you, my own notes, not necessarily this one. A clean version of this will come to you, as well as this. If you want the raw version, I'll give it to you for sure. So now we're on the numeric types. Numeric types, there's a lot of things that you can do with numbers in Python, amazingly. You know, there's plus, there's minus. Yeah, there's the plus, addition. Okay, I'm gonna do this because the other ones, there's you know, minus, multiplication. Hopefully that one doesn't cry. You know, division. So there's 2 types of division: normal division and integer division. I'll show you the difference in a second here. There's also exponent. This one right here, and also like some nice functions to go like absolute value, maximum between 2 numbers, so max, or like a few things, max and min. There's a lot of nice things that you can use right away. You don't have to implement them. And the good thing about numbers in Python as well is that they are compatible with each other. Like you can't say that for C or C++, you have to convert integers to doubles if you want to, work with them, or you just have to have everything doubles, and you don't have like the nice integer kind of functionality. So yeah, we're just gonna, like it's very basic. So you go 12 plus 1, there's that, and we go 12 divided by 1, which is 2 at least, so it's not a trivial answer. And there's actually something very interesting here. As you can see, I divided 12 to 2. And if you know like how the domain works for these, is that if add and subtract things together, the domain is integers, but the range of the values that comes out is still integers. So when we do add together, it's going to be an integer at the end. But like for the operation, a division of operation, the closure of the division of operation is actually not integer. To close that operation, you have to include the rational numbers. So right here, it's just like implicitly just gave us a rational number, which is 6.0. Although this is still integer, but let's say we had to go with something like 13, which will have some fractional part for sure. So it'll be nicely fractional. And as I said, this is a good thing about Python. That it's very easy to work with types, like numeric types, because most numeric types can work with each other, and especially the basic ones. And to kind of like add to this division, as I told you before, there's another kind of division, which is the integer division. This one will round it out to the next integer, so it'll be 6. For certain operations, this is nice. We'll use this later. We're like, what do you use this for? We'll use it later. I found a way to use this. So that is always like, if someone made it, someone always figures out how to use it. So which is great. But yeah, so just to kind of like add a little bit more, the functionality in here. As I said before, there's absolute value. So we can go minus 25 here. It'll be 25. And yeah, as you can see right here, I just put minus at the front, and it recognizes the minus number, which is quite nice. I believe you can do this. It'll be a -1. So some languages don't support that. So yeah, we're lucky. We're kind of spoiled in a lot of the functionality in here. And yeah. So like we'll add one more here. The max and the min, they're very similar to each other. So max, as you can see right here, you type it out. It says right here what you want to do. So like that's 12 and 6. What's the max of this is going to be 12. Yeah. So that's it for numbers. Take a tiny 2-second break. Okay, nothing in there. That's good. Everybody's good, hopefully. And for the next part, we're going to talk about strings. And yeah, so what are strings? Well, what we're really talking about here are strings and characters. So a character is pretty much anything that, like you can kind of store as like a certain value. But sometimes they have like, they have some graphical meaning, like the number C, the byte something translated to the letter C, or like the byte X something translated to like the number 1, that kind of deal. So it's really like some mapping, and this is kind of like a general purpose kind of like a value, right? But like if we combine them together, that's really what a string is. So a string is like a group of characters. And yeah, so strings are unique in that it's actually like a very basic data structure. And because it's a data structure, Python kind of gives us a lot of different functionality to access what's in there, right? So let's do like a very basic A, B, C, D, E, F, G. Okay, so I have a string named A, B, C, D, E, F, G, or a string with the value A, B, C, D, E, F, G. And as I said before, it's a data structure. So we can actually access every part of this string. So let's say we want to access the first part of the string. How do you do that? We just go use the bracket notation. And bracket notation, we put an index in there. The most basic case is that we put an index in that square bracket. So you put 0 in here, and just to iterate, like indexing in Python starts at 0. So the 0th part of the string is going to be right here. As you can see, it's A. It's A right here. So I'll play this. Oh yeah, sorry. They didn't define it. Okay. I'll get to these errors later. But yeah, so the 0th one is A, and the last one is what 0, 1, 2, 3, 4, 5, 6. So the 6th one is going to be G. So that's basically how you'd access, like a very specific part of the string. And now, the good thing about this square bracket notation is that you can actually, amazingly, take sections, which is, that's nice. And we call this slicing. So we want to slice this string out. We want to take the first 3 right here. So what we want to do is that starting from the 0th one, the A one, 0, we're gonna take we're gonna go up to the 3rd, and we're gonna include that. So we're gonna go up to the 4th, but not including it. So what we're really trying to do is that the next number right here is that I'm gonna go up to the index, but not including that index. So I wanna take ABC out. So I have to go count up to D. So 0, 1, 2, 3, and I know that part's not going to be included. So I'm going to play that, and it's going to be A, B, C. So just to kind of reiterate here, the first part right here, so the string, we're going to call it M and N. M being the start index, and if people have the index, I've been using it already very liberally, but an index is pretty much the number assigned to it, depending on where it is in like an ordinal term, like an ordinal value. So in terms of the ordering, I'm going to assign each of these a value to order it with. And the first one here always have this 0 as its ordinal term, the ordinal value. So the index would be 0. If I'm kind of getting complicated in how I'm explaining that. But yeah, so this is going to be 0, this is going to be 1, this is going to be 2, 3, 4, 5, 6, indefinitely for how long as how the string, as long as how this, how long the string goes. Then okay, so go back to it. N would be it's very specific here. You have to always be careful of this one. It means that go up to nth index, but not including the value at n. So as I said before, in our case right here, we start at 0. So 0 here, 0, 1, and go to the 3rd index, but don't include it. 0, 1, 2, the 3rd, don't include it. So ABC. So just to kind of like add another example right here, we're just going to go a string. We can start 1 and we'll end at 5. So it should be from 1, 2, 3, 4, 5. So it should be like B, C, D, E. I'll play it right here. And yeah, B, C, D, E. So this is called slicing. And there's actually additional ones that you can do with slicing. You can actually tell it how many steps it'll take forward. So I'll do that right now. A string. So 1 to 5, but we only want to take every other one. So let's go with 2. Actually, take 2 steps. So what we do is okay, start 1, B. I'm gonna do 2 steps, 1, 2, D, 2 steps, 1, 2. But actually, it won't be there anymore because that's over 5. This is actually 0, 1, 2, 3, 4, 5. So it won't include it. So it's gonna be B and D if we run this code right here. This path right here. And that's BD. So I'm going to add the last part in here in that, and there's an S right here. S being the size of the step from M to the next value to take when we slice the string itself. Okay, let's go. Yeah, thank you. Okay, thank you for people who are explaining. Thank you, Daniel, for explaining to everybody, keeping my flow going. Very, very nice. But yeah, so that's the basic way of using the string. There's actually a lot of different functions around the string, and actually very specifically, it's not a function, it's actually a method. And I'll just touch on what a method is very, very briefly right here. I was just going to go back when we said in the variables that everything in Python is an object. And if you're very familiar with object-oriented programming, objects would have attributes, which are kind of like, attributes, I guess, that inherit to itself, right? So let's say you're a dog object. A dog would have 4 legs. So you have legs equals 4 as your attribute. If you're a person, like a human, you'd have 2 legs because those the ones are hands. So your legs are equals 2. So that's really an attribute. A lot of these are going to be talked about by Carson in the next Carson and whoever it is. Sorry, I forgot. For the next part, which is kind of covered by classes. But I just want to give it a little bit of background here because, as I said before, everything's an object. And because they're objects, they have attributes and they have methods. And methods are functions, like things that you can, like routines and like instructions that you can use with the very specific context of that object taken into account. So in our case, let's copy this string here. A string right here, go down here, next part of code, a string, right? There's a lot of things we can do with this. So a string, and I told you before, to do a method call, we have to put dot. And as you can see, it already gave me a lot of different things. We can use, this is a lot of different things we can play with, but I'll tell you a few of them for now. Upper, what it does is that take this string, turn everything into uppercase. So I'll play that. Everything's uppercase, which is awesome. But the thing is so let's uppercase, let's assign it to something. Uppercase string, because we want to make it lowercase. So we go down here. Dot lower, and I'll just return back to the being A, B, C, D, E, F, G. There's a lot of these. There's a lot of these functions, and you can see right here. And as you can see, they're very straightforward in how they name it. Capitalize means that make the first letter capital. Case fold. Actually, I don't even know that one. We can try it out. ABCD. I don't know what it does, but okay, there you go. That's not part of the lecture, unfortunately. But there's a lot of these. There's a count right here. Actually, I'll talk about count because actually that's one of the things I'm talking about. Counting being that you insert something in here like a substring. So let's say ABCD, and we're going to count how many instances of that is in there. So I play it. There's going to be 1. So let's give it something different. So let's put something ABCD. So there's going to be 2. Oh wait, amazingly, there's 2. So there's a lot of these. As I said before, some really interesting ones. We can actually even go find. So what can go find is that let's say we want to find this string pattern right here, and as it's string, but you can actually just put like 1 because 1 is also a string. But just 1 value is also a string. But yeah, so we'll play this right here, and there's going to be, and when it says number, it's 3. What it actually means is that, I'm going to put right here, is that returns the first index of the occurrence of the input, right? So I put it there, def. Where does def exist in here? And this, the find told me it's at 3. So let's go 0, 1, 2, 3. Okay, so that's that makes sense. All right, it makes sense. So yeah, string is one of those. There's also another one that does the same thing, but it returns an error to you if you don't have it. So how about this? These two are the same, so I can actually comment this out, you guys. Actually, if you haven't realized yet, sorry, I'm just telling you this now, is that whenever you're in a code block right here, the last thing that you put in there is the output of this value right here. Just letting you guys know. I forgot to tell you in the really rough guide of the notebook, but the last thing it says right here, this is the one that pumps out from here, unless you do a print statement. Unless you do a print. So like if you print a print right here, ABC, it'll do like 2 things right here. But if you don't have the print, it'll just run the last one right here. Okay, so just let's decide. But the index right here does the same thing as find, except that they handle errors differently. So So go right here. If you go right here in string find, and I want to look for fed, this just returns -1. And for string find, if you read the documentation later, like how it works is that it'll tell you -1 if you didn't find it. The difference for this versus index is that if you put fed in here, it'll tell you it's an error. It's not found. So depending on how you want to use it, it might be very useful to you. So the last few things I'm going to talk about in like we call this the things that we can use with this is that there's two more things I want to talk about. Is that there's the replace. I want to talk about the replace, a string that replace, and it's very straightforward enough that like you want to go A B C, then you want to relate to like X Y Z. You can play that one, and it kind of just replaces every instance of A B C to X Y Z. Yeah. And finally, the last one, which is kind of maybe a very different way we'll do it, is that go here. I'm going to use the bracket notation again. Is if you use negative numbers. What happens with negative numbers? And what happens is that it goes from the back. It goes from this side right here. So 0, -1, -2, -3, -4, -5. And it works pretty much the same as how you would think it would. As long as you're ordering it properly. So -1 will be C. Then you can actually kind of cut it from there. Go from -1 to -3. So it's going to be -1, -2, -3, but not including the -3 right here. So it's going to be B and C. This is going to be, oh, that doesn't work. Oh, weird. But okay. Wait, it doesn't work. It should work. Wait, let me check my notes. Unprofessional moment. Yes, it doesn't work. Okay, it doesn't work. Okay. You have to, yeah, it doesn't work properly. Okay, don't just forget about that part. But yeah, you can actually use this negative one right here. If someone can double check that for me, that'd be awesome. Yeah. You can use length for sure. So yeah, we're moving on to the next part, but you can definitely use length at the end. But actually, I forgot one thing. Very, very smart to use length. The length and the count are the same. Or sorry, the length, I forgot to tell you the length, which is not in here because I'm using it for a different part. I'll talk about length right now to get to the end. And I forgot one part of the slicing. So we'll go to the advanced slicing right here, is that you can actually go like this. Start from the first one, and you just go colon, and with nothing in it. If you go nothing in there, Python kind of understands it as go until the end. So start from 1, which is going to be B, and it just goes up to the end, B, C, D. I'll take this out so it's a little clearer. So it just goes till the end. And similarly, if you forget the start and you just go put it to like a number, what it means that we're going from the start right here and we're ending up to, but not including the fourth one. So 1, 2, 0, 1, 2, 3, 4. So just ABC right here, or BC. Okay. 0, 1, 2, 3, 4. Sorry. A B C D, because this is the fourth one. Okay. So yeah, you don't have to use the length in there. But yeah. So it starts from 0 at the front, exactly. But it starts at -1 if it's -1. I would just think about it like kind of like the anchor is always the first one, which is 0. Then you kind of go back. If you're indexing with a negative number, you're kind of like going backwards. But because there's nothing to the left side of it, you kind of do it like a modulo where you go to the other side. You kind of go like this. So let me just illustrate it in like in a different way right here. So we have this data structure of the string right here, A, B, C, D, 0, 1, 2, 3, right? So when we index forward, right? So we add 1 to the index, we're kind of going this way, right? So with a positive number, right? But if we're going with a negative number, we're indexing backwards, we're kind of like going this way. But because there's like there's nothing there, Python kind of decided like we're gonna go, sorry, we're gonna go here, then we're gonna go backward this way. So the direction of the negative is that way. So negative goes that way, positive goes this way. So if you, yeah, so just kind of like think about it that way. So the anchor is always the same. Like the anchor is always 0. Yeah, exactly. Like a modulus. I don't know if, yeah, if super familiar with how the modulus, kind of, I use the modulus word, but yeah, that's like the modulus, a modular, yeah, modular arithmetic. Okay, all right. Okay, double checking in here. Okay, we still have around 30 minutes until our first break, and we just have like a couple more or 3 more things to go through, so it's good. So let's do the next part. Next part right here in my list is basic input, and this is amazingly short. So basically, it's just this input and whatever prompt you want to do. So like, give me something there. Then you want to kind of assign the value that coming out related to some variable. So like my var right here. Then you can use that variable whatever you want. Depending on what environment you are in, it actually acts as differently. And this nice thing about the collab notebook is that it gives you this nice UI. Hello world. Then press enter. Then it kind of prints out. It goes to the next part. And as you can see right here, it actually waits out for you to give something. Right. So this is So if you wanna, like in this case, you wanna input something in here, you just gotta wait it out from here. Waits out for you, then it continues after. And the important thing you have to note is that my var is always a string. Like if you don't do anything like this basic way right here, it's always a string. So let's say like if you use the my var +2 like this, play it. If you put 1 in there, it's like, oh, I can't add them together because they're different types. Like going back to there, it's different types. So the good thing probably is to convert this to some value, use a type conversion as we talked about before, and just to make sure it works. So this always returns a string. If you want to clarify that a little bit, yeah, that's it for input. So now we're gonna go with the operators, Boolean operators. I talked before. There's like the Boolean types, comparison operators, conditionals. So we'll talk about Booleans first. Hopefully, a lot of you guys have been are what do you call this? Acquainted with the Boolean logic. We should be pretty much like manipulating true or false. And there's also like a few things that we kind of like use to compare each other, which is like or and not. So these like operators, and they work exactly as how you would think it would work. If it was like you doing some mathematics and whatnot, like Boolean math. So you go have a true or false. Obviously, the or operation always return a true in this this kind of statement, so it's true. And you can do other things like this, like true and false, which is going to return to a false, because and the truth table for the and is like that. And finally, if you negate something, you just go not false, which is going to turn into true. Okay, so what can we do with this? There's a lot of things we can do with. We can compare, and because as I said before, a lot of things kind of like evaluate to true or false. We can compare their truthiness and falseness. We can do some kind of operation. So we'll try to get like truthiness, falseness, and certain things first. We'll use, and for that case, there's a thing called comparison operators, right? So there's a few things we can do. We can do equals equals with kind of like is an equality. Actually, I should make a text on this. Delete this one right here. Okay. Okay, there you go. Okay. Sorry about that, guys. So I'm just gonna list out whatever the comparison that we have is that we have equal equals, which is equality. I practiced that so many times. Less than equal to what's this? Less than, first the basics, greater than equal to. I'm gonna put it in here. Greater than equal to, greater than equal to, and not equal, which is not equal. Right here, and these things return bools, like these types. And as you can see right here, you can use these operations as well to kind of like get some kind of Boolean formula, right? So we'll have an example in here. Go down, please. So 1 equals 1. That's true. So 1 equals 2 is not true. Yeah. 1 equals 1 or 2 equals 1, and it's going to be a true because like you can combine it together, because this one returns a true, this one returns a true, this one returns a true. You can use the or to kind of combine them together, and it returns a true. And a concept right here, like if you realize there's a concept right here that kind of like we're using, and it's called an expression. And right here is that there's this one expression right here that returns a value, like a singular value, and there's another expression right here that returns another singular value. We can combine them together, and that's really how like we use these like statements together, so we can form like a very complicated like Boolean switch, right? And we can use that switch in like a different, like a use case, like later on, like say if you have a loop, you're going around, and if the number that you're accumulating becomes this, you can exit out, right? So this is usually like this is how we're gonna do that. We're using these expressions right here, and we're using this operator right here. Let's see if I have any questions. What is true or false? Output true. True. Yeah. Sorry. I'm asking very quick questions there. True or false? Output's true. It's really because of this. I'll show you what it is. Because like there's in logic, there's the or operator, right? If you input the values of like, so let's say or A or B, right? So this is A, this is B. So 0, 0, 0. Sorry. Wait. Let's clear this up a little bit better. Okay. So we're trying to figure out what A or B means, right? So we go put A and B right here, and we're gonna go right here: false, 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 true, true, false, true, and true, right? So this is the output. So this is pretty much just Boolean logic. So like false or false, which is gonna be false. False or true is gonna be true. True or false is gonna be true. So this is like the truth table. Like it's pretty much Boolean logic. That's why like the or works that way. It's kind of hard to explain a little bit more elementary than that because maybe but yeah, I could talk to you about ask me about Boolean logic a little bit more later, but that's just Boolean logic. It's saying true is true. Oh yeah, okay. Yeah. Thank you, Carson. Thank you, Elisa. Yeah. Okay. Cool. Translate the images. Sorry, I got distracted there. Okay. I gotta focus. We gotta focus on this, including myself. Sorry, everybody. I gotta focus on this, because usually when I do these courses, I give time to people can ask me like directly, and the chat is very, very new. So sorry about that. I'll keep that in mind for future cases. So next up we have here is that, as I said before, these are expressions, right? And expressions amazingly can be assigned to variables. So let's say one expression we have is going to be 1 equals 1, right? Another expression, equals 2 equals 2 equals 1. Yeah, you have to be wary about these equals and equals. Equals is the assignment operator. This is the equality operator. Very, very careful. Yeah, very careful, guys. Then we can actually use this now to go or other expression. So just to keep that in mind, we can use expressions like that. And like there's another thing that you can do is you can actually group expressions like this to kind of like tell Python like I want this worked on, kind of like this, or 1 equals 3, that kind of deal. And we can actually, we could go that, and it kind of tells you operate on this one first, and operate at this one, and operate in this one. Then solve the thing. So yeah, this is true right here. Look at options. Okay. So we have now expressions and Boolean logic and whatnot, and we can use this in a lot of ways. And like the most easiest way, like the most common way to use it is through if statements. Right? I said before, like it's just sticking an expression in here, and we can act on something, right? So let's say if 1 equals 1, which is pretty much like true, we'll do something. Print true. This is true. I agree. Okay. So print it, and it does it, right? And the thing is, if we make this into false, so this one evaluates to true when if the expression in this if part evaluates to true, it executes what's inside of the block. And actually, there's one very important thing that you've noticed here. Like, there's a block, the concept of a block. And what is a block? It's pretty much just like a piece of code that kind of like under a domain of like another construct, which is if right here. And the way we've actually the way we've separated it out from everything else is that we put a tab right here. This tab right here tells us that this print is the code block. This print belongs to the domain of this if, right? This if has some code after it, and if it's true, we're gonna run that code. So now, so that's a block. So I'm just gonna write this down for you right here. Print is within a block under if. Run this block only if the expression in if for version to if, I guess, is true. So as I want to give you like the anatomy right here is this is the if statement, right? This is the expression that we're using as the input, and the part right here is the block. Just to kind of like solidify that, the anatomy of this construct right here. And if we play it, it goes true. So if we change the value of this to being false, so 1 is definitely not equals to 2, and that's false, it won't do anything, right? That's it. So now there's a lot of like the if construct has a lot of different like additional functionality to it, and there's 2 things that we can do. Like we could actually add an else statement in here. So what happens is that if this is false, we'll run the else statement. So print this is false. Right, so you go in there and it prints this is false. And I just want to kind of reiterate in here. I'm gonna label this as print. I'm gonna kind of make this a little clearer. This print right here, print this is true. Right here, and I'm gonna go in bottom right here, print this is false. This is within the else block. So it's under the domain else block. So it doesn't actually run if the else, like if this is false, or if this is true, it doesn't run. So we can just double check it with you. It doesn't run. And there's actually another thing in here that we can do called an else elif, which means really like else. If this one right here on top of me is not true, check me again. But I have like a conditional statement. So let's go 1 equals let's say like 3 equals is greater than 2, which is definitely true. This is again true. And what happened here is that as soon as one of these blocks run, the entire thing doesn't run anymore. Like we won't run the else anymore, because this is the one it exits out. So we write in there, and this is true. So if we add one more in here, like we add something in the bottom right here, another else if, which is going to be true, is once again. It's oh, sorry, we're actually right here. Sorry, I kind of blundered that one. So we're still right here. We're still right here because like it goes in here. The precedence is that it goes from top to bottom. So it goes, is this true? No. is this true? Yes, exit. But if it's not true, let's go like this. Is this true? No. Is this true? No. Is this true? Yes. So it'll come out in here. And ultimately, the last one that it comes out to is going to be the else, like the ultimate one that, like, whatever happens, this will happen if everyone else fails. So that's how you kind of combine the if else's. Like, don't abuse this too much. A lot of people would complain about that at one point, but there's a lot of different ways to kind of abuse this kind of like else if. But that's it's just me talking about random stuff. But yeah, so if else right here. Nicely enough, Python has a lot of other things that it wants to do. Let's say you have this kind of construct right here. If one is great, actually let's put it in the variable. Like, so a number equals 5, right? If a number is greater than 3, then let's say another number equals 2. If not another number equals 1. Like, it's pretty much nonsensical, but like what we're trying to do is that, like, depending on what number we're using, we're gonna try to figure out what to do with, like, what to do with this assignment right here. So number is 5, so it becomes 2. But let's say this one is like 1, and it becomes 1, right? And we just put this like if else right here, and this one, like, let's say you forgot to do something right here, it just goes like this. Right here, you forgot the else, you play that 1. But let's say what if happens is that if it's 5, it's greater than, right? Or actually, yeah, okay, play that first. Then okay, I gotta go because like it remembers the last context. So if another number is not described before, it'll play it. It'll wait to get another number. Oh wow. 1 second here. Yeah. 1 second, guys. This didn't run as expected. Weird. Okay. Wait 1 second here. 1 second, guys. I'm gonna trying to remember. It's obviously not bigger than another number. Okay, I'll just put another value in here, some value, because it's kind of like overlap. Okay, so what happened is that if you put some value behind like this if, it's this code block, it doesn't get run, right? And if you assign it later, it's gonna fail at one point because you didn't assign it. So a way to go around this is that we can do this actually. This is called a ternary operator. It's kind of like an aside now. So we assign some value, and like we would assign it like the one that can, like, if number A, so we're gonna do is like 2. So 2 if a number is greater than 3. So it kind of encodes this information. But if not, so it always reminds you to put something in there. Let's put 1 in there. So in this case, it always prints out, right? Wait, I can put a number in here because it kind of takes the number from the top. Oh, geez. Okay. Sorry about that, guys. Equals 3. So play that in there. And we can change this into a value. And we go like 1 right here. Kind of, goes around. Yeah, it follows this kind of like syntax right here. Sorry about that, guys. I kind of got, what do you call this, tripped up with the other one here. But yeah, so basically it just kind of like encloses this if else right here, if else. So this one here is pretty much equivalent to this, equivalent to a value equals none if a number greater than 3, a value equals 2, else a value equals 1. Okay, so yes, so that's really like their equivalent. And yeah, that's it for if statements and whatnot. So let's go in here. If you have any questions right here, we're gonna take a quick break right now. Come back at like 2:30, and we're gonna use all that we've learned right now to make something. So yeah, take a 10-minute break. If you have questions right now, answer it as much as I can. But yeah, 10 minutes, 2:30, guys, 2:30. Or let's make it 2:33 or 2:32. So, oh geez. Can you show your screen back? Of course. Sorry about that. I'll put you guys at the side. Give me a second here. I realized that I can put you to the side and I can talk to you. There you go. Is this structure of a variable? I'm not sure what you mean by structure of variable, but what you've done right there is that you're the object. Yeah, you have an object variable. That's correct. Then the function is the technical term for the function is actually a method. The method belongs to that object variable that you have. And I'll draw it out right here. And Carson is exactly right there. It's a class. That's like, if you know what a class is, that's exactly what it is, right? That's exactly where you're getting it. But like, so you have this object variable right here. The object variable comes from some class, right? It's like the class is kind of like the template. Okay, well, the next session is very good for this, but I'll just make a very, very basic, super high level description of it, and like Carson will cover it, and we have like 10 minutes anyways. So if you don't mind, Carson, I'll just do like a very quick one. So what happened is that so thanks. So there's this object you have right here, right? The object, let's say, that's obviously like a circle, and we have like a mold right here of a circle. Okay, actually, let's make it a little nicer. So we have a sphere right here, right? A sphere, and we have a mold of a sphere right here, right inside, and there's like a mold and like a thing right here, like in let's say we're casting it metal, right? So we have a mold right here, right? And the sphere right here is like what the thing we made. So in this analogy, the sphere, the product itself, is the object, and the cast right here is the class. Class right here is the cast. What I mean by that is that like the class kind of dictates what the object would look like. It's kind of like a template, and the class itself has the ways to kind of build that object, right? So when you see a class being defined, like the class will specify, oh, the object will have like in case of like an animal, let's say like class animal. The animal, oh man, bad handwriting right here, sorry friends. There's legs. Oh, animals have legs, animals have brains. And there's gonna be 4 brains, and animals will have like digestive system. Yeah. So at least they can move around, they can think, and they can eat, right? Sorry guys, my headphones kind of fell off. So what happens is that like, oh, I'll make an animal. Okay, we'll take the class, pass it through the class, comes out with an animal. So it has a digestive tract right here. So it makes a digestive tract. There's some legs. Then there's some brains. So weird looking animal. We didn't define if there's eyes and whatnot, but so what happens is that like the class kind of dictates what the object will have. And in your case, the object variable, the class said we're gonna have the function, and the function is a very specific attribute. It's pretty much just a method. It's a method like that. It's not structure, but the object has it. It's something inherent to it. And whenever you call that function that's a method inherent to it, it always knows what you are. It always references what you are. So it always knows like, oh, I'm animal, I'm walk. Like say your function is to walk, right? Or your method, really, the proper term is a method. The method's to walk. Tell that animal to walk, like a person would walk differently from an animal with like 4 legs, right? So it's very inherent to itself. And that's really like the thing about object-oriented programming in Python and whatnot. Is like, you got to remember your context. The context is your object and your methods and whatnot. And yeah. Thanks, everybody. Yeah. And yeah, Carson will cover this next week. Yeah. So if you have any more questions, we have 8 minutes, or 4 plus 2, 6 minutes. Data type. Yeah, the data type itself is the class. Because what happens is that this, because whenever you do something like this to Python, like when you go, I actually want to zoom in a little bit more. Okay, when you go type some object, right? What's doing is that it's retrieving you the class. Like in most cases, it'll retrieve the class. So the class of the object. And that's how you use to construct that object. So the data type, the thing is like these are kind of like different concepts in general. Because data types kind of like work at a different abstraction layer. But yeah. Oh, thank you. You're welcome. Sorry. Thank you for the compliment, and you're welcome. Yeah. And I said before, if you are having trouble following, I will give you my copy of this. You'll have this. I have another one of this that's completely cleaned up with documentation. So I'll give you that as well, so that you can reference them. Sorry, I'm reading the comments there. Yeah, but sorry, what I'm trying to say is that you'll have this notes right here for you. So if you just want to sit down, relax, and listen, absolutely fine. I do suggest though, the next time when you go to Carson's class, and Carson and Keegan, right? I can't remember who the other person is. I want to mention his name.
Keegan.
Yeah,
Keegan's gonna do it.
Yeah, Keegan. Yeah, Keegan. Please review them, because you know, like he might not have the same setup as me. We're all different instructors. We all work relatively independently of each other. So yeah, please review them, and you know, like these are accessible to you. So, and you can, you know, like once you get them, make a copy, then do whatever you want. Add more notes and experiment more. And you know, like the good thing about the collab notebook is that, you know, it's there. You don't have to set up. You can use your tablet amazingly to run this. You can use, you know, you could use your laptop, you could use your phone. The phone not very optimal because the screen's small, but the tablet works perfectly. You can use I think you could even use your PS4, PS5 if you have a PS5, lucky enough. Good on you. To study Python, so you can, like, let's say like you're trying to find an excuse to buy a PS5 to your, you know, like partner or parents, like, oh, you know, I could learn Python using my PS5. Then when they come and check you out, you open the web browser and go to like collab.google.com, you know, typing out Python functions in there, and they say, oh, that's awesome, you're doing good there. Yeah, thank you, Daniel. Thank you, Carson. Yeah, thank you, Golem. Sorry if I'm saying your names wrong. Yeah, this is, like, as I said before, they will cover this next class. Yeah, if I'm not explaining enough, yeah.
Seems like people are really interested in class and objective oriented, and
Yeah.
methods, those kind of things. So basically, we will cover that in the next week. People, please save your questions to the specific content that Peter was talking and is talking. So and save all the class related questions to the next week.
All right, Daniel. Daniel. I'll try as hard as I can to say it properly. Daniel. Yeah, we have a few more minutes here.
Well, Peter, so I think we are about the time to do that 10 minutes break before we start the section 2. And great lecture. I think it's really good, you know, introduction and the fundamental for the Python.
Yeah. Thank you, everybody. Thank you.
So, yeah, we're gonna be back into 2:40, and if you have more questions for Peter or the class in general, feel free to post it in the chat box. And if Peter wants to keep talking and answering questions, feel free to do it.
I'm your and you know, like in this 10 minutes, I'm your entertainment. You know, I'm the streamer, so you know, there's no tips and whatnot, unfortunately. Just kidding, guys. I watch a lot of Twitch. So
Nice. Yeah, I recall the times. Anyway, so people, I've posted a couple images in the Slack channel because I can't post them here. So those are the list indexes and the truth table. I will continue posting images for like the course related materials to the Slack channel, so you can all take a look. I've also pinned them to the channel. Like if you are late or missing anything, you can always see the pinned items. Yeah, keep an eye in the Slack channel as well, and feel free to ask any questions in the Zoom chat here.
Yeah. That's a good idea. Is like, say next time I do this course again, I'll keep in mind to put the truth table, because I've kind of implicitly thought that people know the truth table, even though it's really not thought even in high school, if you think about it.
Yeah, truth table is only taught in the electrical engineering and computer science, I guess.
Yeah, it's true.
Yeah. And also that list index is really, really easy to understand. I found that when I was learning Python, this chart actually helps a lot. So
yeah. Thanks, Carson. Yeah, there's definitely any these kind of material is good. Like I'll keep this in mind for next time I make this. Have these pictures ready. Yeah.
Cool. Peter, if you want to take a break, I can play some music, so you can take a break and drink some water.
Yeah, I've been literally drinking this water here. Yeah, I'm just gonna say here, relax, do some.
Oh,
If you
Daniel
want
said
to,
he can just sing.
Oh, okay, that's actually I thought you were telling me to sing. Okay, that's good, because like
No, I
if you
said I just
don't-
can play some music, so you don't have to keep talking. You can take a break for a few minutes.
Yeah, for sure.
Well, Daniel, is your last chance. If you really want to sing, please go ahead. Otherwise, I'm gonna play music.
How can we check for truthy values here in Python?
Say it again, please.
To see if a variable is not null or a variable exists.
Oh yeah. Where is this? There you go. Yeah, you can. There's I told you before. A few cells back, there's the very specific none type right here. You could actually go if you do that. If none, if x equals is none. Actually, the very specific thing is none. Then you do something. Do something right here. To check if a variable is defined. You know what? I never actually thought about that. Usually what you do is that, like, let's say like x plus 1, or let's say something undefined, right? Undefined. The thing you have to do is that this actually would do an error, and you catch the error. This one I'll discuss later. So I think this is probably what you're asking, if that something is defined, right? If a name is used. And what we can do later is that well, actually, I'm gonna cover this later. Like, this is an error about it, so we're not kind of lost in that in that uh, in that part. Does that answer your question?
Yeah, thanks.
Okay.
we'll cover try except next week.
Yeah, I'm gonna cover try except in the next. Let's see how far we are.
Yeah. So we can use try except to catch undefined.
Yeah, right here.
But we rarely do that. So
yeah, so it's actually at the end right here, unfortunately, but not near the end. But I'm gonna cover that part. The next few parts are relatively quick because like a lot of it has already been covered. But yeah. Excuse me.
Okay, how Peter is ready, and it's time for the second section. And great, it's all yours.
Okay. Hello, everybody. So for the first thing that we'll try to we'll try to kind of put everything together, at least the current things that we know, to something maybe just even tiny bit useful. So what I'm thinking right now is that um so sometimes when you watch news and you kind of watch American news, and they always tell the weather as Fahrenheit. And we live in the Celsius world, like pretty much every civilized society. um but yeah, so we kind of just want to have this tiny little program that we want to reference every once in a while. Maybe like I'm bad at mental math, so I want to have some kind of program that this tells me what Celsius it is based in Fahrenheit. So what I have right now is that like Fahrenheit equals Celsius times 1.8 plus 32, right? So we want to get like the Celsius out. So really it's like Fahrenheit minus 32 divided by 1.8 is like the formula to Celsius. And what we want to do is that we want to have like a tiny, very, very tiny program that kind of just like takes my input, then spits out Celsius, right? So what we can do is that well, first let's get the input. So Celsius input. I just realized that this text right here, even though all right, the markdown didn't help me out too much there. I'm just gonna do this here so that we can see it very nicely on our, there we go. There we go. So we're gonna go our Fahrenheit input. It's actually H right here. I'm missing an H. Sorry guys if I'm spelling it wrong. Fahrenheit. Let me check my notes so I spell it. Fahrenheit. Okay. You're gonna be a little bit correct, input, and we said input before. Then the prompt is that enter your temp in Fahrenheit. Right here. And as I said before, the input is always string. So we want to be doing this right here. We want to be converting it to float. Because if you don't, it's it's gonna say something weird to us later. And our formula is that Celsius equals Fahrenheit input. I'll take up this Fahrenheit here. And I'm just gonna convert it almost word by word right here at the top. You can see 32 divided by 1.8, and that's Celsius. Then we'll just print it out. Celsius, go on. Okay, ABC Celsius. Okay, there you go. And now we're done. Actually, we're done, which is nice. So let's say when someone in America says it's 40 degrees, and you're like, oh man, that's really hot. Really, what they mean is that it's 4 degrees. So it's like, oh, okay, all right, some context. Okay, that's good. Which is, yeah, so very simple, kind of like we combined everything that we know. As you see, there's an integer right here. We did integer or we did like a float to integer subtraction. So it turns to float, it divides by float, Celsius is float, and turns this is 4 by 4. And the thing is like, oh man, that's really long. We can actually kind of like make it real nicer. So we can go round. Is that nice, right? It's not round. We call this round function, kind of like how we call the print function, but we'd actually put another number in there because actually, if you see checks around here, we'll do it round in here. It was telling me about a second, so we just put 2 in there so that it's kind of cleaner. We play in there and we go, oh, it's 40 degrees freezing. So it's 4.4 degrees, which is not, is pretty cold. And I see right here is 4.44 degrees. It's not actually very clear. Like 4.4, we don't actually know exactly what it means. And I'll tell you some fun little thing right here called like an F string. The F string right here is like a formatting string. So we put F at the front, and you what you can do is that we'll put this in here. Celsius. We'll run Celsius again. So there you go, and we'll put in here. I'll type in the current temperature. Sure, and you put this block right here, this curly bracket. You put the value you want in there, and now we've pretty much just put we're putting that value, we're interpolating it into the string. That's actually the proper term if you're going to search for it in different languages. It's called interpolation. We're interpolating the value Celsius or whatever it is, and Python will automatically convert it into a string. Because when you do strings like these together, formatting, Python actually does it very, very nicely. Like it can just knows, oh, it's a string. Or I'm sticking it into the string, so I'm going to make you a string first. So it kind of like implicitly runs the string function. Let me just double check what Python I'm in. I realized that we might actually crash and burn if this is not Python 3. But give me a second here. I'm going to add some more niceties in here. Degrees C. Yeah, sorry guys. Like I don't know if you can copy and paste that one. I'll copy and paste it on the chat if you wanna pay, yes, thank you. Fahrenheit with an H. Yeah, thank you, Daniel. Yeah, and yeah, exactly. String literals, exactly. Template literals. F strings, template literals, exactly. It's the same concept. It's just to have the different names in different languages, so I've nicely formatted this out. I'll play this. I'll put 40 again. Oh, there you go. It's nice. Degrees C. Yeah. So this is our first application of it. We'll make something a little bit more complicated. Let's say what we're gonna do right now is that you know how it is when like we live in the civilized world, we measure our height in centimeters, and someone asks you, like, you go on a date and say like, how tall are you, which is actually a very bad question in a date, in my opinion. But or like these are the Tinder, when you're chatting on Tinder or like whatever you are, and they say like, how tall are you? That's a pretty appropriate question, but they don't want to hear centimeters because like you can put a big number and like, ooh, cool, but they want to be feet and inches so they don't get deceived. So we're gonna go feet and inches, a little bit more complicated. And like, how do we do this? We'll break the problem out first, right? So we know 1 inch equals 2.54 centimeters. Then we know 1 foot is 12 inches. And we're gonna try to like build like a way to kind of like from centimeters to inches, right? So what we know for sure is that feet is how many feet there are would be inches divided by 12, right? And at the end we would we want to put like 12 feet and like 8 inches, that kind, or 5 feet and 8 inches, that kind of deal. Like 12 feet person would be too tall. So yeah, so like the inches is actually very, very specific. Inches, which is actually a remainder is actually has to be what do you call this? What's this? Inches divided by 12, but the remainder of this operation, and luckily in Python we actually have very nice operation for this. So let's start it off with the print. So we'll just copy and paste some of these. Right here. All right, CM measure, and input your height in centimeters. Come on. Then what we do is that we have to convert it first into inches. So we gotta go inches equals 2.54 times, of course, we actually, yeah, that one. So now we have the inches. Then we want to get the foot first, right? Just like just the foot part, not the after the decimal point, right? And I said before, we have the slash slash double slash division. It does integer division, and what it means is that it just gives you the integer part, not the fractional part. So we can actually use that very nicely. Feet equals inches divided by 12. So now this would be just the number part, or whole numbers, just the whole number part. Then we want to get like the remainder now, right? The remainder of this operation, and the remainder very nicely can be is very nicely operated by the modulo operator, which is in Python is like percent. So we go inches remainder equals inches and 12, because there's like, yeah, we do it 12, then we get the remainder. Okay, there we go. And you know what? To make it a little bit nicer, we'll round it. We'll round it to nothing. No